Hello everyone and welcome to Learn LEED Chapter 1. This is mainly going to cover the core concepts and explain a little more in depth what LEED is and what we mean by a building assessment model. I'm Trey Hauk and let's get started. So starting off, we're going to, just as an overview, go over impact categories, life cycles, the triple bottom line, integrative and iterative processes, and finally, last but not least, systems. Starting off with impact categories. So what are impact categories? Well, they're a guide for point allocation for each credit in the LEED rating system, and the higher on the list, the higher the prioritization. So if you look at one, that reverse contribution to global climate change, that's going to be the highest priority, whereas 07, that enhanced social equity, environmental justice, community health, and quality of life, is our lowest priority, which isn't to say it's not a priority, just that there's bigger fish to fry. This can be found from the LEED version 4 impact category and point allocation development process. And while the actual priorities are constantly shifting and changing, this is a general good rule of thumb. You see a lot of priority on reducing emissions and reversing the elements that are causing global climate change. So starting off, we have reverse contribution to global climate change. This is mainly involving reducing greenhouse gas emissions, not just from the building and building operations, but also for transportation to and from, for the materials that we use and the water usage that we have. We're looking at reducing the amount of water that is being taken from outside of the system and bringing it in. And last but not least, we're looking at a cleaner energy supply. So moving from things like burning coal to solar, to wind, to geothermal. And then we're also looking at some potential global warming reduction from non-energy drivers. The book doesn't provide too many examples of this, but the above greenhouse gas emissions are essentially what you need to know for the exam. Second, we have to enhance the individual human health and well-being. This is essentially supporting occupant comfort and health as a result. We want to make sure that people aren't inhaling or being exposed to any harmful chemicals while they're living and operating inside of buildings. And we're just trying to ensure that human health is also being protected along that entire building life cycle. So not just when people are in the building, but when people are building the building and repairing it. And ensuring that it is that it is good for humans throughout the entire process. Next, we have protect and restore water resources, which, as the title might suggest, it's water conservation, water quality protection, making sure that we still have clean, potable drinking water, and we're looking at the protection and restoration of water regimes and natural hydrological cycles, sorry. If you don't know what either of those are, don't worry, we'll be getting into them a little bit more later on in a further chapter. But as we move on to number 4, we'll be going over protecting, enhancing, and restoring biodiversity and services to the ecosystem. So basically, we're looking at ensuring that all the organisms, be they plants or animals, have the space needed to continue to populate and grow, and that we aren't destroying their only habitats through creating space for our own. We're wanting to prevent the encroaching of invasive species and essentially making sure that we're taking care of the land responsibly so that other people other than us humans can inhabit them. Going on from there, we have promoting sustainable and regenerative material resources cycles. And we'll go into this a little bit more in depth further on, but essentially we're looking at reducing the amount of new materials we're extracting. We're looking to build new buildings with materials that have already been produced, excavated, etc. We'll go on to kind of what these cyclical non-depleting material cycles mean, and we're just looking to also reduce the environmental impacts throughout the material's life cycle. Next, we have build a greener economy, which is to enhance the value proposition of green building. We're looking to strengthen the green building industry and supply chain, promote innovation in the integration of green building products and services, and incentivize long-term growth and investment opportunities and support local economies. And we'll be talking about this a little bit more with our core concepts. But environmentalism isn't just about being green, it's also about being viable. And that's what this covers. Last but not least, we have enhancing the social equity, environmental justice, community health, and general quality of life. And this is more kind of a byproduct of following all of the others, but we're looking at promoting communities that can embody these values, and not just that, but apply them for everyone, whether they be rich, poor, majority, or minority. We want to make sure that we're providing a sustainable future for everyone. So, with that being said, it's important to understand what life cycles are. Now, there's a couple terms you need to know before we get into this. First, there's cradle to grave, where materials are extracted, manufactured, consumed, and disposed. Now, this is unsustainable. Basically, it's going from the cradle of being extracted to the grave of being tossed in a landfill. We have cradle to cradle, which is that same cycle as above, extracted, manufactured, consumed, but instead of being disposed, we're reusing it for other purposes. And obviously, since it's not going to a landfill, ultimately that's sustainable in the long run just because we're not relying on new resources. And then last but not least, we have embodied energy, which if you might recall was on one of the earlier impact categories, and that's essentially the total amount of energy used across the cycle of cradle to grave or cradle to cradle. There's two ways that we look at cradle to grave and cradle to cradle cycles, and that's through life cycle assessment and life cycle costing. So first, there's life cycle assessment, which focuses more on the environmental considerations and takes a look at the upstream or extraction and downstream, the processing and delivery activities, and we're looking at the activity or at the energy used to extract and process and deliver these materials. Whereas for life cycle costing, we're looking at the cost considerations over the life cycle of a product, basically short-term versus long-term savings. There's no point in taking a cheap route at the beginning if it's going to cost us much, much more further down the line. Now, these two aren't mutually exclusive. You can use life cycle assessments with life cycle costing, and that is frequently done by people who are trying to get LEED certified buildings. But those are the differences between the two, and just good to know. This is an example of the applications of life cycle costing. So we have a more efficient and less efficient HVAC system. And while the less efficient HVAC system initially costs less, you see that in the long run, it actually ends up costing more just from maintenance costs, operating expenses, and general nickel and dime paper cuts that begin to whittle down your budget over time. Whereas the more efficient HVAC system might not look as desirable at first, you can see that it actually saves you $2,000 in the long run just from those energy expenses and maintenance costs being less. Now, when we talk about cost, there's a lot of mention about the triple bottom line. And what that is essentially a balance between the economic, environmental, and social aspects in order to become sustainable. At the end of the day, this is what sustainability is. It's not just protecting the environment, but it's also protecting the interests of society and the economy at large. Environmentalism, it's no longer just for hippies. So on the environmental aspect, you see what we're kind of looking at with, pollution prevention, resource preservation, recycling, reduce, reuse. But then we get into the economic and the social, where we're looking at the cost savings of sustainability. We're looking at what methods save us the most money in the long run. We're looking at what methods are going to bring us the most money in the long run. And for the social, we're looking at the health and well-being of these opportunities, or ensuring that they're distributed to everyone equally and ensuring that it is being applied in a way that is fair to everyone. There's no point in, say, enacting a ban on beef, which would be great for the environment, if it's going to, say, crash the economy and cause people to riot in the streets because they want their burgers. So going on from there, we have integrative and iterative processes. Now, the integrative process design, or IPD, is a design process in which teams from multiple disciplines collaborate from the beginning of a project to meet sustainable design objectives. It's more time earlier for less headache later. Everyone is a part of a larger team so that we're avoiding conflicts and avoiding disputes later on where there's a foot misalignment between the electrical and the mechanical, and now somebody's got to budge when they don't have room to do so because the plans were mismeasured and the wiring is going straight through where the HVAC ducts should be. Now on the other side, we have the 3 phases of IPD. Ignoring the little technical difficulty here with that slide, I don't know why it's causing that. But we first off have discovery, which is the pre-design phase, wherein we're performing an analysis of the energy and water usage before any actual site work, seeing what's going to be viable. Then we have the implementation phase, wherein prior research is used to help solve the owner's project requirements and the basis of design. Essentially, we're then coming up with solutions based off of the problems and observations that we got from the discovery phase. And then last but not least, we're looking at occupancy, where the actual building performance is measured against expectations. This is after our solutions are implemented. It's basically the review phase and where we see where we went right and where we went wrong. Now, iterative design process, on the other hand, or IDP, is the process used during design wherein research is conducted, data shared, and the design refined. And you can kind of see this cycle here of first we research and collect the data, we analyze it, share it with the team, receive feedback on how to proceed with that data, and then refine it further before repeating the whole cycle again. Now, the difference between the two is that integrative is all about including everyone from the get-go. It's about ensuring that everyone is on board and everyone is contributing so that we are avoiding any headaches. Whereas iterative design process is all about a continual refinement. It doesn't necessarily have to involve everyone, but we should be constantly collecting, analyzing, and improving upon data that we've received. It's important to distinguish the difference between IPD and IDP, as that's something that people commonly mix up on the test. So I don't really have any good suggestions for you as far as memorization, but a general rule of thumb is that acronyms help you to memorize them better. So for integrative process design, it could be I poked dinosaurs or something like that. So, something silly to get it to remember in your head. Now, last but not least, we have systems. So there's open enclosed systems. And this is kind of expands a little further upon the cradle to cradle and cradle to grave that we were talking about earlier. Now, what we normally see is cradle to grave, where we have resource extraction, then it gets manufactured and processed, then we buy and consume it, and then when it breaks, we dispose of it. This isn't sustainable because we're constantly needing to extract new resources in order to fuel that open system. Whereas if a closed system, we can see examples of that in nature. We have trees falling, leaves from trees falling off and dying. Those dead plants then decompose and become minerals and nutrients for this soil, which is then in turn absorbed by other organisms, such as still living trees and still living plants, allowing them to grow, and then the whole cycle repeats. At no point is new material consumed in that. And so when we're talking about sustainability, we really want to shoot for these closed systems. Now, with these, there's positive and negative feedback loops. There's negative feedback loops where the systems self-correct and stay within a particular set of parameters. A good example of this is thermostats. You set it to a single temperature, and if it goes above or below that, it then course corrects so that it goes back to that desired temperature. Whereas a positive feedback loop is where the output from one iteration of a system causes a positive feedback, promoting and intensifying future iterations. An example of this is global warming, climate change. We have melting snow, which leads to a increase in the sunlight absorbed by dark surfaces, the temperature increases, our cooling system usage increases, which results in higher emissions, which then results in more climate change, which causes the whole cycle to repeat more and more and more until it snowballs out of control. So, ending things there, I just want to leave you with a question to kind of think on, and why is it important to look at several perspectives when we're focusing on sustainability? I'll let you think on that, and I'll see you for Chapter 2 of Learn LEED.